Welcome to the 9th video of our soil testing series, where we'll look at soil stability. Soil aggregates can either be stable, fall apart, slake, or completely disintegrate, disperse, when they become inundated with water. This stability, or lack thereof, is driven by both physical and chemical attributes of the soil, such as the type and quantity of exchangeable cations, the soil texture, the type and quantity of clay in the soil, organic matter content, and the salinity of the soil. Slaking occurs when weak soil aggregates break down into smaller fragments as a result of rapid wetting, and the clay particles in the soil swell up. This results in the blocking of macropores, which in turn reduces the movement of water and air in and through the soil. Dispersion is a chemical process whereby these swollen clay particles separate from the soil aggregates when the soil is wet, and they become suspended in the water, often the cloudy colour we can see in puddles or dams after it rains. The test for soil stability is best set up 24 hours before looking at the results. Place rainwater or distilled water into a shallow, clear cup or dish. Tap or bore water may alter the results due to chemicals and minerals present and shouldn't be used. Locate the paddock that you want to assess, and from a hole dug, place 2 samples about the size of a small marble, one from the topsoil and one from the subsoil, into the water without shaking or stirring the samples. If you're interested in looking at the impact of mechanical disturbance on the soil, you can take a small sample of the soil, mix it with water, and mould it into a small ball and place it into the water. Make sure to label the samples so you know what you're looking at. Fast forward 24 hours and check what your soil has done. Slaking clay will slump and fall apart in the water, forming a small blob of mud. However, the water will remain clear. Dispersion will result in a milky layer forming around the soil crumb. Using the Soil Health Scorecard, we can assess if soil stability is poor, unstable structure, aggregates break down and disperse, milkiness of water, and gets a 1. Fair, evidence of slaking, the aggregates break down but there's no milkiness of the water, and it gets a 2. Or the aggregate remains intact, no swelling of clay particles, and gets a 3. We can see that soil stability has a weighting of 2. This means we can take our score, times it by 2, and this soil health factor is moderately influenced by decisions we can make as land managers. Dispersive soils are usually sodic, so more than 6% of all their cations are sodium, and they're structurally unstable, which can result in surface crusting, reduced seeding emergence, increased runoff, and an increased erosion risk. These soils shouldn't be disturbed, especially when they're wet, further impacting their stability. Soil organic matter reduces slaking of the soil by binding those mineral particles of the soil together and slowing the rate of wetting, and by reducing the disintegration of the soil aggregates into those smaller particles. Gypsum acts to replace the sodium with calcium on the clay surface, binding those clay particles together, forming a stronger bond. This is with gypsum, this is without gypsum.